Okay, guys, so this is going to be climate and water, topic 8. We're going to start in our note packet, right? And we're going to be, if you take a look at the notes that you have in front of you, we're going to start on page 3, Roman numeral 2. We're going to talk about the water cycle. Okay, so what is the water cycle? All right, the water cycle is the movement of all the water on Earth, and it involves all phases, solid to liquid to gas. So that means water from the ocean, water in the air, water that is coming out of the air, meaning rain and snow, all that movement of water. So these next couple things that we're going to talk about are going to involve those. So here they are, right? We take a look at this diagram. All of the letters that you see indicated are going to be the first letter of what we talk about. So what is evaporation? We see evaporation, we see an E here going up from the lake. We see it from here in the ocean, right? It is water that is changing in the form, going from a liquid to a gas. That is evaporation. Next, we have transpiration, right? T for transpiration, right? It's going to involve, we see here, this T is going back to the trees, right? So transpiration is releasing of water into the air by plants. Next, we have precipitation, and we see it here coming out of the clouds. Precipitation is water condensing and coming out of the clouds in the form of a liquid or a solid, meaning rain or snow. 4, we have runoff, and runoff is exactly what it sounds like. We see the R's here, right, where the water is running off the surface, right, into rivers and lakes and oceans. So when it rains, that water is going to run off and flow over Earth's surface. 5, we have infiltration. Right? Key word is that in. So we look here for the letter I pointing down, right? And I apologize for these over here, pointing down into the rocks and soil. So water is going to permeate or enter Earth's surface. Infiltration is water goes into or permeates the Earth. I know this permeate is a new word, but we're going to refer back and forth to it. 5, we have evapotranspiration, right? It's the combination of evapo, meaning evaporation, right, and transpiration, right? So it's both evaporation and transpiration combined. So essentially it is all of the water that is coming from the surface going up into the air. Next, we have the water table. And we can see the water table is this line right here. And I'm going to kind of sort of highlight it, right? I know it went over, right? But notice that this is soil and rock up here. This is the water table down there. So it's that boundary between water in the ground and the dry soil above it. So this area here is just dirt and rock. This below it is dirt and rock that has water inside of it. Right, you ever go to the beach and you're digging in the sand and the top part of the sand is dry, and then when you get down far enough you see water kind of seeping in? That would be the water table when you hit that boundary. All right, now these next couple things are all going to be things that affect infiltration. So water entering the soil. So the first thing is porosity. So the key word is that pore, right? And a pore is an opening or a space in between the sediments, right? We all have pores in our skin. When that skin gets clogged, you get a pimple, right? And then you try and pop the pimple to open up that space. So the amount of space, right, between those sediments. Now, if we relate that to water, the greater the porosity, the greater the infiltration, meaning the bigger the opening, the easier it is for water to get in. Think of it as a door. The bigger the door, the easier it is to walk through. Right? We can see it here in this picture. Greater porosity on the left, less porosity on the right. More space in between, less space. Right? And some things that affect porosity are the shape of the actual sediments. If you take a look at sediments that are rounded, you can see here on the left that there is a lot more space in between them than the angular or the pointed sediments. So water is going to have a easier time getting through. So round particles have a greater porosity, which means a greater permeability. Water can get into it easier. Next, we have packing, right? if you take sediments, you can either pack them closely together or space them more openly apart. And you can see from this picture, right, if you had to get from the top to the bottom, you are going to go through the loosely packed sediment much easier than the closely packed. So as a result, your closely packed has a lower porosity or lower permeability. And you can relate that either way. Loosely packed, greater porosity, greater permeability. The third thing is sorting. And again, when you look at that, if something is sorted, everything is the same. All of these particles on your left are the same size particles, whereas the ones on your right are unsorted and mixed. And there is going to be an easier time for water to get through this. So sorted is going to have a greater porosity, therefore a greater permeability. So that takes us to permeability. So to permeate, right? In order to permeate means the ability of water to pass through the soil. So water can enter the soil. All right, and we can see these different types. All right, the greater the pore space, the easier it is for water to pass through it. Right? Then we have capillarity. Capillarity is really cool. Right? It's an attraction that allows water to move up. So ever walk home from school on a day where it rained earlier, right? And it's not raining when you're walking home, but you step in a puddle and the bottom of your pants get wet. By the time you get home, that water has creeped all the way up your pant leg, probably up to your knee. Why did water do that? Well, the particles in between the soil allows water to actually grab onto it, and water is so sticky that it climbs up. All right, so again, think of your pants stepping in a puddle of water. Even if just the bottom is wet, by the time you get home, halfway up your leg is going to be wet. That is capillarity. Then we have saturation. We talked about this, right? And this refers to how full the soil is with water. Slope of the land, right? Is water going to be able to infiltrate the soil if you're, let's say, on the side of a mountain? No, water's going to run off the surface. If it's flat, let's say like the field outside the classroom, you're going to easily get water seeping in, permeating, or infiltrating because it has nowhere to run. Right? So steeper slopes will not allow water to permeate or enter that soil. Most of that water is going to run off. Okay, so that takes us through the water cycle, right, and different things that can affect how water enters the ground. I hope this helps with the second part of the topic. All right. If you have any questions, reach out to me and I will gladly answer them.